this in. Okay, first of all, for those of you that don't know me, Jeff Goff. I currently work for Moonfruit in the UK, downtown London. And just as a disclaimer, this talk won't be so much about Perl, but about ways to visualize your test suites using Perl and JavaScript. I'll be doing a little coverage of test more and Devel cover. Very little coverage because the JavaScript library is the main focus of this, how to do quick and easy visualization using JSON and the data generated from test more and Devel cover. Finally, the entire package originally is on a VM, but is now static, was wrapped up using Dancer and the visualization library d3.js, which is a pretty impressive graphics library. What it lets you do, in our case, after too large the screen, all right, is produce a graph of your current test suite coverage. Just to clarify what's going on, each circle here represents a folder in your test suite. So you have the outer T/directory. If I were to mouse over the image, you'll be able to see names pop up for the folders and subfolders. The green and red spots here are the actual files, with the inner ring being the most important. That determines shows how many tests in your unit passed in that test file passes. So for instance, the strings.t file passes completely, all green. The outer ring is how much of the module, the strings or shapes module or mass module, is covered. So that is a better representation of how much work is being done, your test suite does to perform, how well your test suite performs overall to cover your data set. Just as a quick reminder, for those of you that do not know about Devel cover or even basic testing, there may be a few in the audience. I'm not judging. Using Devel cover gives you the tool cover, and in our case, to generate the graphing data. As shown here, we use the report flag, report in JSON format, and for your test suites, just make test. And I didn't have access last night to double check this, but the harness Perl switches should let you format JSON out of the files of the test coverage. This will all be on GitHub by the end of the week. I'll have a URL at the end of the talk. And by the way, if you have any questions, especially about the JavaScript portions, please feel free to jump in and ask, because that's more or less the entire content of the talk and gets fairly detailed. I'll zoom in just a little bit so you see one of the actual files. These are all generated using SVG. Originally, this was a actual SVG, HTML5 canvas. So you can do all sorts of things with this in HTML5. For instance, I was working on a package to actually animate the bars. So when the image loads, you would see the red take over as an animation and swing the arc down live on screen, just for a little more visual flair. Unfortunately, this is a static image, so this is all you get right now. Sad to say. These are all SVG elements, simple arcs like these down here, simple circles like these, styled with colors, and with the stroke attributes that you can apply to any CSS element on your page. Diving a little bit deeper into this, again, this is all driven off one JSON file. So the entire display here is read from one JSON file, which in our case is a large tree of nodes, one node looking like this, with a name for your with a name, in our case, the test directory, so t/filter, and files underneath that to run, fisheye, tree filter, and the passing percentage of tests, and the overall coverage for that. You can go into more detail and create, and as part of your JSON file, add in the overall coverage for that filter, if you like, for the filter directory, sorry. And add in whatever features you like. For instance, one feature I experimented briefly with is adding a opacity layer. As you can see in the background, we have the dark green shading to light blue, light purple, whichever, shading to even lighter purple. So you add opacity to layers to visualize and stack the data so that you see things at a glance. And you can be even more sophisticated if you'd like, and do the same thing that I'm doing here with these arcs down here to the entire of the image, so you see at a glance how much coverage you have in the entire test suite for management. And also in the expanded view, this also lets you see the size, by the way, is the size of the test suite. So you take a look instantly at this MBLC. They have two test folders about the same size, and one with a little bit more activity than the other, and a smaller test file down here. So you see at a glance activity and progress as your test suite goes from red, represented over here, to green. You see more activity and get a better idea of how the test suite is developed over time in terms of visualization. So let us dive into the actual JavaScript side. I will warn you that JavaScript is heavily closure-based, closure and callback-based, because they don't do OO quite the same way that Perl does, obviously. They have the real model. So the first thing to do when you're doing a display is get a display onto the screen. Ordinarily, you would think that you would just add a SVG tag to your HTML. Unfortunately, thanks to Microsoft, it doesn't quite work that way. You actually have to use the D3 select method in order to search through the body of your HTML and attach at the end an SVG element. Thankfully, this also lets you resize the canvas, so if you have, say, a mobile phone view of your application, you can use that to shrink or expand the contents of the test suite display. The SVG element gets its width and height dynamically at runtime when the page loads. And you can also do various transforms, such apply to a G, which is the D3 term for a graphics context. For, if anyone remembers Quick Draw GX, they use the same technique. Not that anyone here remembers. The transform there simply takes the current canvas that we have displayed here and nudges it down slightly to have an inset in the image. Now, I warned you beforehand about how callback-rich D3 is, but this is actually a blessing in disguise, because you can take those callbacks and apply them to any of the D3 format types. You'll notice back here, oh, that's coming up actually. You'll notice here that we have essentially a closure going on inside here. we tell D3 to read our JSON file, which is the tree structure. And afterwards, in parsing, what it does is it calls this function one time, which will seem a little bit odd shortly. So if there are any errors, it will report that as part of your, in the callback, and you have the root of the JSON document that's now been parsed out from a tree of nodes into a series of flat nodes. The name node is not pluralized because that's how it was in the sample, and that's how JavaScript people deal with this. They assume that the select all is enough of an indication that the node here is actually a list of nodes. That's the first thing that threw me when doing the analysis, going through and working on this, among many things. And again, in here, the data comes in and we select all of the nodes in that flattened list and put them into our node variable. And like I said, JavaScript loves this callbacks, so we have an additional callback here to create a class attribute, which gets used to say whether the given node is a leaf or a regular node. So we can put a green label on or a blue label on as part of the image. It's all rather inside out and upside down compared to how we would normally think of these things. But it's a useful exercise, and in some ways it's really handy because I originally did this with a different format that D3 provides, and all I had to do in order to use the new bubble layout was literally change maybe 10 lines of code, where it told D3 to use the new format, obviously, and a few lines of code in callbacks. So in actuality, it is much more flexible than it looks. I think there are fun things hiding here for Perl programmers to pick up on, little tricks. But one of the first tricks that you find out fairly quickly is how to do functional programming in JavaScript, which would be what the node.filter function does. This is the main display that generates all of the blue images. How am I doing at time? Excellent, excellent. Let's make sure. Anyway, this is the function that draws the blue background. Now, you'll see we have a filter here that returns basically whether the node has a child or not. So if the node has children below it, it is a filter. Therefore, it gets a blue circle displayed by this. And afterwards, one of the features that the code here does for us as part of collecting part of the datum and select all here, it provides us with the radius of every node in the layout, and down here provides us with the X and Y coordinates to display. So it's handling all of the fun layout work that you would have to do otherwise in order to pack all the circles on the screen in the right way. It handles all that for you. Very big relief. And again, the way this works out is yet another callback. So we have the radius callback here, which takes our circle node and gives it a certain radius. We're not quite done yet to display displaying this. The append down here. Thank you. Aha, thank you. Yeah, excellent. The circle node down, the circle call here appends the circle to the list of VGA properties that we're building, SVG properties that we're building up. All these circles and all of the arcs and all of the text that you're seeing are all appended to the SVG document. as part of the node listing. So it's, again, somewhat non-intuitive. Thank you. Moving on to the actual arcs that we're seeing here as part of the green and red sides. These are also a callback. Now, there may be a fancier filter function that can work with multiple combinations, but the way that I've done, the way the documentation does this is you have one pass to build out all of the circles in the background that have children, and one further pass to build out all of the circles that do not have children, i.e. the green nodes. Again, all callback driven. And the way that it works, unfortunately, as far as I can tell, is that you have to do separate filter passes for each of these steps. In other words, if you have multiple attributes along with the green, red coloration, and blue, whatnot, you need to make that a separate pass. So we, as part of this, add a path which is our cover arc, which is the coverage arc on the outside of the image. And we tell it to fill it with green, just make sure. Yeah, so that's the basics of images. This part is, again, where some more non-intuitiveness shows up. Because we have a function over here that does the percentage math to convert the percentages back to radians for handling, for passing on to the sine and cosine arguments, which you don't have to worry about in the D3 core. JavaScript uses radians for instead of degrees, like normal math people do. But the thing you'll notice here that I have the radian conversion command, and down here I have functions to do work. Because of the way, again, JavaScript is laid out, and I'm not entirely sure why this is the case. These functions, I believe, need to be inside the scope of our original d3.json call in order to properly work. I move them around, and that breaks things because, again, of the way JavaScript works. I make no judgments. It's an interesting way to work. And you see a little bit more here. Specifically, these, thank you, these two lines down here, specifically the outer and inner radius calls. These you would think could be refactored into D3 SVG arc, outer radius, inner radius, becomes your radius block. That's not the way that works, because these actually modify the return value. So if you have a cover arc for one side and a cover arc for the other side, which would be this part and this part of the display, you're going to end up modifying your cover arc object here twice, which threw me for a good 45 minutes trying to figure out why that's the case. The objects here that you see, cover arc and SVG arc, those are the equivalent of Perl's hashes. Not hash references, but hashes. So when you call back to that, you get that value. But luckily, that is almost the end of the story. What I showed you before is just a taste of what the SVG library, the D3 library can do. This right here was the inspiration for what I was working on, a bubble layout. Over here we have scatter plots. You do diffusion patterns, animations. This over here rotates a 3D globe in JavaScript live on the screen. This over here is what else here? Something I actually remember. This is where I got the idea for the rings. Over here is a cellular automaton model. And down here, here, and here are plots used in the New York Times website. The New York Times website crew use these three for rendering, such as this. This was an election day preview. This was a model for epidemiology. And over here you have graphic networks that actually can move about the screen. So if you touch an element on the screen, it moves. It's a really neat model, and all you need to give it is a JSON file to play with or a CSV file to play with. And I hope, if nothing else, I have managed to inspire you to check out the model. This we provide on my broken GitHub account shortly, probably by the end of the week, once I get a few kinks worked out. Other than that, thank you. Any questions? Okay then. Thank you.